Internally, this 10 is converted to this an integer object. Integer object can be pointed by object reference is valid. If that is valid, object 2 equal to 10.45 is also valid, right? Because nowadays what? Object obj2 equals to double dot value of 10.45. Here we say object obj3 equal to, because x, this is also valid, because object obj3 equals to character dot value of the character is the char is converted to character, char is converted to XML object obj4 equal to hello. So right side is string object. This is string object. String object. String is also child of object class. Okay. Object obj5 equal to so new of student 1001. Right. So it's a student object now. Student object having ID and name. Student object. Student object also can be pointed by object reference. Right? So all 5 lines are valid now. If they are valid now, object 1, object 2, 3, 4 to valid. Now obj 1, 2, 3, 4, 5, rather taking 5 variables, all are what type now? Object type. Leave it, leave it. All are object type. Okay, similar type now here. So what we can do here now? Object. Create one object array, right? Isn't it? All these elements are object type now. So we can group all these 5 elements into an array now. Array is the collection of similar type of data items. So definition, according to definition, we are just creating the object now. Object array equals to null obj array equal to how many objects we are going to give now? New object 5, right? Allocate memory for 5 elements. Then you can say obj array of 0. 0 equal to what? 0th index. 0th index we are giving. Then obj array of 0 just like obj 1. It's like obj 1, 1, 2, 3, 4. 0, 1, 2, 3, 4. It's 10.45. This is your x. Okay. It's your hello. Yes, okay. Okay. To complete objects. Now look at this is an array of, it's an array of what object, right? Array of different types of element or not? 0th element is an integer. First element is a double, then character, then string, then it is a student. So we are able to keep multiple different types of element at the same time. We are not losing the definition also. According to definition, it is an indexed collection of finite number of homogeneous data items. So similar kind of data item, all are what type now? Object type, right? All are object type, but the values are here now. Different values are there. Okay, so individually if you take, you have to do like this. Individual 5 variables. This is an array of object. Or you can do initialization. Object obj array equal to what will directly generate? New of object 10, 10.45, x, hello, new of student. Okay, this is also going to be right. Is or no? or even this is not mandatory. New object is not mandatory. And your initialization just you can do like this. Object array, zeroth element, first element, second, third, and fourth element, right? And how do you process them right now? For I equal to 0, I less than obj array dot length I plus plus println obj array of I. Okay. Or if you use enhanced loop for object obj in obj array. Delete one object from the object array. And this will then println obj. Okay. Just you can take this line only. In a shortcut, very shortcut, you can take like this. Take an array. This array is a 4-type object array. It's an object type, so any type of element can be stored in this array. If it is an integer array, only integers can be stored. If it is a float array, only float can be stored. If it is a character, if it is student array, only student object can be stored. But if it's an object array, any object can be stored. Okay, so in this way we can create an array of different types of elements. But still, there are certain problems here. Problems are here, what we are able to manage it different types of elements, but a lot of conversion happens internally. Integer to integer, float to float, right? Second thing is that there are two more problems here you can see in an array. The drawbacks of an array I'm talking about. Drawbacks of an array. Drawbacks of an array. What is the first drawback? Array is static. This is the first drawback. Array is static. Its size is fixed, right? Size is fixed. It does not increase or decrease according to the need of application during runtime. During execution, its size does not grow or shrink. It is fixed. Whatever size you have given, those many elements, elements can be stored. Memory gets allocated for those many elements. Let's take an array of size n. Array of size n. So memory will be allocated for n number of elements. So maximum how many elements we can store? N. If you are trying to store more number of elements, then program will crash. In between, program will stop, terminate, terminal somewhere. Program will stop execution. So it won't allow more than n items. If you are trying to keep less number of elements, then a good amount of memory gets vested, right? Because memory allocated for n elements, but we are not consuming them, then a good amount of memory will be vested. So if you are using less, memory gets vested. If you are using more, it won't allow to store more because the size does not change during the runtime. Okay, during runtime, dynamically it won't change from time to time. It's a fixed. Okay, that's the problem with your array. Second thing is array contains homogeneous elements, right? Array contains homogeneous element, but we can manage it to have heterogeneous element if you take an object array. But generally, if you take integer array, it can have only integer, right? Float array will have only float. Employee array will have only employee. So it contains only homogeneous element. The third, the biggest problem also here, like it does not have ready-made method support. Ready-made method, it does not have any inbuilt method support. Like by using arrays, we can group the elements. Array can be used for the grouping the elements. But after grouping, if I want to do some manipulation, I want to do some processing, then we need to write the logic for that. For example, one array is created. I want to insert an item at the given index position. We don't have such predefined method by just calling that method that item can be inserted at that index position. One array is there. I want to insert a new element at the fourth index. We can't store directly, right? We need to write the logic for that. We need to push all the elements to the right side of the fourth index. Then that will be a place, right? Fourth index. Then we can place a new element. We don't have any ready-made method support for adding, for removing, for searching, for sorting. We don't have any inbuilt method support. We need to write our own logic for that. Being a programmer, we need to write our own code for that. It has no ready-made inbuilt methods are not there. Okay. So the array is only suitable for grouping the elements, but not for processing the elements. Okay. These are the three drawbacks of an array. Array is static. Array contains only homogeneous element. It does not have any ready-made or inbuilt method support is not available for this. Any kind of operation we are going to do it now, we need to write our own logic. You might have seen in your C++ also, we have stacks, queues, other linked lists. So we don't have it ready-made over there. Just there is a concept of linked list. Linked list, that's what they're called abstract data type. They are called ADT. Abstract data type. It means something, there is a concept behind it, that is a linked list. But what happens in linked list, how the element will be inserted in the linked list, inserting an item at the beginning, inserting an item at the end of the list, inserting an item at the middle of the list, removing an item from the beginning of the list, removing an item from the end of the list, inserting an item at the desired index, desired after the node. So these things cannot be done. There is no ready-made method for that. We need to write a code for that. That's why people say no. Data structure programs are very big programs, right? 3-4 pages of programming, write all these operations you have to do it. So all these things are given in a different format in Java. I think. Okay, so they're like array list, linked list, stacks, queues. These are all data structures. The entire data structure is given in Java in the form of a collection framework. In the form of a collection framework. So all the problems which are associated with an array now, what are the drawbacks of an array? All these are overcome by using the collection framework. Okay. So collection is what? Collection is a dynamic insights. Array is static, collection is a dynamic. So dynamic is what? Runtime it will grow or it will shrink, increase or decrease according to your requirement. The size can be changed. There is no size restriction first of all. In case of array, we can store finite number of elements, right? Fixed number of data items. We have to define it first. But in case of collection, there is no fixed size. As you keep on adding the element, the size of the collection will grow. Automatically it will keep growing when we are adding the element. There's no size limit here. Okay, first thing. Array is static, whereas collection is dynamic. Array contains homogeneous element, whereas collection can have both homogeneous and heterogeneous element. And it has no ready-made support. Collection has a plenty of ready-made methods. For each class, there are number of methods by which we can perform all the basic operations, inserting, deleting, searching, sorting, then different kind of operations we can perform by using the ready-made methods. So all these problems are overcome by using the collection framework in Java program elements. Okay. So if someone asks you what is the collection, what do you say? In very layman form. What is the collection? Collection is what? I'm not asking programmatic. What is the collection? Someone's collection is what? Group of things, no? Collection is a same thing. See, collection is a group of things. If you define a bit more, the group of things could be similar kind of things, or it could be different kind of things. Okay, right? So collection is a group of things. That group of things could be homogeneous element or heterogeneous element. Similar kind of element, all might be integers, or it could be integer, float, level, character. Different elements can be also collected into one group also. Okay, bit more if you define it again, it could be homogeneous or heterogeneous, or it could be unique or duplicate also. We can group unique elements. Sometimes there is a requirement of grouping the unique elements, grouping only the unique elements. Okay, and sometimes there is need of grouping duplicate elements also. So the collection could be a group of unique elements, or it could be a group of duplicate elements also. Okay, or it could be a group of sorted items, sorted elements in order, or it could be the unsorted form also, right? Sorted or unsorted, sorted or unordered form. Okay, of what size? Of unlimited size. Of unlimited size. So that is the definition of your collection. So you can say collection is a container. Collection is a container object. Collection is also an object. Collection is also an object like other objects, but collection is called as a container object. Why? Because collection is carrying other object. If you talk about your bag, bag is an object, and what you keep inside bag, that is also an object. Whatever keeping inside the bag, that is also an object. But bag is also an object. But bag is carrying other object, so bag is called as a container. So like that exactly that collection is like a bag where we can dump everything. But the thing is that here bag has a limited capacity, but collection has a no limited capacity. So as you keep on adding the elements into that bag, the bag will keep growing it. Then you keep removing, the bag will decrease also. So it is a like dynamically it can increase or decrease. The size can be changed. At the runtime, its size can be changed. Okay, according to the need of the application, change. Look at the same thing. Just go through this. Whatever I said now, what is an array, and if it's integer array, it can have only integer elements. You try to give something else, give an error. We can't keep 10.2 because this array is an integer. It's an employee array. Each element must be an employee object. If you're trying to keep a customer object, compilation doesn't come because this array is of what type? Employee. So it will have only employee object, but we cannot store the customer object. So problem is here, array is fixed in size. Three drawbacks are there. Array is fixed in size. Its size does not increase or decrease according to the requirement of the application at runtime. In case of an array, if you are trying to store more number of elements than the given size, program will crash. If you are trying to store less number of elements, a good amount of memory will be wasted. Array can have only homogeneous element, but by using object array, we can overcome this problem. Okay, so just we have discussed how to get this object array. Individually, you can take objects, or you can get object array. You can assign one element, or you can go for initialization. Then display the arrays by using the for loop here. It does not have a ready-made method support. Arrays does not provide any inbuilt method to perform any operations. Whenever we are trying to perform any operations on those elements, array elements, we don't have such method. So that's why by using array we can only gather the objects, but cannot manipulate them efficiently. We need to write our own logic for them. So all these problems can be overcome by the collection. Collection is a dynamic in size. It will grow or shrink automatically during runtime. Collection can have both homogeneous and heterogeneous element. Collection is complete designed based on the data structure. That's why every class, each class in the collection framework provides a number of inbuilt methods. It supports a plenty of ready-made methods to manipulate the elements in the collection. The collection is not only used to group the elements, not only for gathering the elements. At the time of gathering, even we can perform operations on them also. It has ready-made methods so that we can do it. So this is a group of things. A group of things could be either homogeneous or heterogeneous. We suppose this is right now. It is a group of, it's a collection now. It's a collection of what? Similar kind of elements, right? All are integers. It is a collection of heterogeneous. Both are collection, but this is a collection of homogeneous, the collection of heterogeneous. Or it could be unique element or duplicate element. See, then this is a unique element. Okay, unique as well as homogeneous. Unique and homogeneous. This is a duplicate and homogeneous. Homogeneous, similar kind of items only. All are integer. Duplicate items are also allowed here. Right? Duplicates are also allowed. But this is the heterogeneous and unique. This is heterogeneous and duplicates are allowed. So it could be a group of unique elements or duplicate elements or homogeneous elements or heterogeneous elements. So collection is a container object which contain other objects. Those objects can be of either homogeneous or heterogeneous or unique or duplicate or sorted or unsorted of unlimited size. N number of elements can be stored into the collection. So collection is used to represent a group of things as a single unit. A group of element can be presented as a single unit by the collection. When I'm saying collection framework, it provides a number of class and interfaces. Okay, number of class and as we discussed now, I told you stack, the queue, all the things, all the operations, all the because the data structure related concepts are there. Stacks, queues, linked list, array list, trees, all are implemented in the form of a collection class here. It provides a number of class and interfaces which is used to represent a group of things as a single unit. Each class in collection framework represent a collection of things. See, actually the hierarchy, complete hierarchy, what are the things we are going to explore? Just we need to understand in collection framework which is the right container to carry your object according to your requirement, according to your application. You have to select the right container where you want to keep the elements. For example, there is a need of grouping unique elements. Then which data structure we should select? Okay. If there is a need of gathering duplicate elements, then which is the appropriate structure? Okay. Or sometimes like in which order the elements we are grouping, like last in first out, whichever element we gather last, that has to be processed first. Last in first out order, the element which is added last, that will be processed first. In that order I want to process my elements, gathering the elements, and the processing will happen in this order. The last element which is added now in the collection, that will be processed first, then which is the right hand structure. Or first in first out, whichever inserted first, that has to be processed first. First in first out, then which is the right data structure. So just we need to understand which is the right data structure to contain my objects here. Like last in first out is stack, first in first out is a queue. So duplicate elements should be allowed, then go for list. Okay, unique elements are only allowed, then go for set. So set, list, queue, map, these are the different classes are provided by the collection framework. Just we need to explore them and we'll see the complete hierarchy, then we'll get to know. So the main objective of collection, the two choices are there here, like when to use collection framework. Very first thing, you do not know how much of element we are going to store. Size is not known to you. You do not know how many elements they are going to do. Randomly, I mean, runtime, it could be any number. We do not know the number of elements. Then array is not the right size. If I ask you, find out all the prime numbers between 1 to 500. Find out all the prime numbers between 1 to 500 and store it into a container. Store it into a container. In this case, we do not know how many prime numbers are there between 1 to 500. If I take the container as an array, as you know that when you create an array, you define the size, right? Suppose you take an array of size 300. Array of size, you are assuming that okay, 300 prime numbers might be there between 1 to 500. So you have taken the array size 300. When you take array size 300, assume there are more than 300 prime numbers are there. What lacks? They cannot be stored, right? We can't accommodate all the prime numbers if it is more than 300. If it is less than 300, unnecessary memory gets wasted. We allocated memory for 300 elements. Memory will be wasted. So if you do not know the size, how many elements we are grouping, if you do not know, then don't go for using array. That is one thing. Size and type also. If you do not know type, if you know the type, then you can say no. It's an integer array, it's a float array, it's a double array. If you don't know the type. So the thing is that if type and size is not known, okay, in that case, collection is the best choice. Rather using arrays, always use the collection. But if you know the type and size, never go for using a collection. Always use the array. If the type is known to you, what type of element we are grouping, and how many elements we are grouping, we know that in an advance. Then go for using an array. Second thing is this: whenever we are sending a bulk amount of data from one place to other place, from one application to other application, or one method to other method, bulk amount of data. In that case, we do not know how much of data we are sending or how much of data we are receiving on. In that case, don't go for using an array also. In that case, we can say collection also. So input will be a collection, then we are sending it. Return type will be a collection, means we are receiving it. Okay. So whenever we need to send bulk amount of data from one method to another method, it is the form of a parameter. When we need to return a bulk amount of data from one method to other method as a return type. Whenever we are receiving as a return type, we are sending as a arguments, okay, parameter we are sending. So in that case, the collection is the best approach to fulfill this problem. Okay. Now look at this hierarchy. So I have to increase the font size, then only you can see this. Look at it now. But is it visible to you that increase the font size? Otherwise, it will be here at the data structure will be here at the. I am reading out this lesson here. First, in the collection framework, the root interface is a collection. I am just reading out. I think it's not visible. Can you see this now? Huh? I'm just reading out because if I just increase the font size now, I will like the hierarchy is completely getting mixed out. That's why. So let me read out. And collection is the root interface. Wherever I written I is for interface, C for class. Collection is the root interface, and it has introduced in 1.2 Java 1. Since beginning it was not there. It has come in JDK 1.2 version. JDK 1.2 collection framework was introduced. Collection 1.2. The collection interface has got the 3 child interface. 3. Very often, sometimes it is 4. They include map is a part of the collection, but map is not a child of collection. Map is a separate interface. So collection has got 3 interface, child interface: set, list, and okay, set, list, and set came in 1.2, list also in 1.2, but queue was introduced in 1.5. Till 1.4 version, queue was not there. Queue concept was not there. Queue came in 1.2. Queue and all its child interface, implementation class, all came. This entire part, queue part is added in 1.5 version. Okay. Then coming to set category. Under set, we have a has set. Has set is a class. It came in 1.2. Now see, this is an interface. This is a class. What is the relationship now between these two? This is a set. This is an interface, a class. This is an interface, a class. Interface to interface is always the what? Extends. one interface extended from another interface. One interface cannot implement another interface. Interface to interface always what? Extension. Class to class always extension. But interface and class is what? Huh? Interface and class. Huh? See, you don't know interface concept, forget now. Huh? Interface to class is what? This class is implementing set interface. Class always implements interface. Okay, interface class like implements. Interface is extends. Class is extends. Class to class extends. Interface to interface extends. But interface and class is implements. Class always implements an interface. No? Huh? What is the rule to be followed? Suppose there is an interface, there is a class. The class implements interface. What the class has to follow? I think this last class I was talking about this. Huh? The very first thing only you are not remembering from every concept. You know? Many times I told this. Interface class. When the class is implementing interface, what the class has to follow? What the rules class to follow? Interface I1 class C1 implements I1. What the class has to follow now? What rules need to be followed by the class? See, if you don't know this, then forget about in any depth concept in interface and all. If you don't answer this, then definitely in the interview you will not ask anything on that interface. Will never ask. The first question if you are not answering. Yes. Online guys, anyone? Interface I1, class C1, implements I1. What are the rules to be followed by this C1? Whenever a class implements an interface, the class has to implement all the methods of the interface. What all the methods are there in the interface that has to be implemented by the implementation class. This is called implementation class. Here we don't call parent child. This is an interface, this is an implementation class. Why is it called implementation class? Because the class is implementing the interface. It is an implementation class. When the class is implementing an interface, the class has to implement all the methods of the interface. Similarly here, asset is a class. This class is implementing which interface now? Set interface. And set interface is extended from where now? And what all the methods are there in the collection? What all the methods are there in the collection? In the interface, no? All the methods are what type? All the methods of interface is what type? Huh? All the methods of an interface is what type? Huh? Yes. What kind of methods an interface contains? Sorry? Yeah, come on. What is saying? interface. Runnable interface లో run method ఉంది. The runnable interface కాదు, ఇది collection interface. Any interface you take it, what kind of methods are there in that interface? I'm asking. See, you won't be able to answer this question. Then what the guy will assume that. First of all, he will tell you who taught you. First of all, he will ask you. Where you learned, who taught you Java, he will ask first question. After that, later the other things. All the methods of a collection of the interface are by default public and with the blanks. Public and what? Public and what? See, after telling this also, you are not able to fill the blank. By default, all the methods of an interface are public and abstract, right? Empty methods are there or nothing? Methods without body. Okay, all the methods of an interface are by default public and methods without a body. Methods without only the method declaration part is there, there is no method body. So all the methods present in the collection is also available now. Set and set is implemented by as. So all the methods present in the collection interface is implemented by which class? As the definitions are present in which class now? As it's something like this. Suppose this interface contain now. Okay, suppose this interface contain a method M1. Okay. Then the class contains what now? Public void the definition here given here. M1 is an abstract method and the C1 is implementing I1. So inside C1 this method definition is present here. What this method does, that is present written inside what? C1. Similarly, the collection interface contains number of methods. We will explore all the methods. Each method I will tell you. Collection contains number of methods. All the methods are implemented in which class now? Asset class. Got it or not? Just understand hierarchy today only. You will see. Asset is a class implementing set interface. Set is extended from collection. Similarly, linked asset is a class. This is a class. This is a class. So class to class is what? Extends. So it is a child class. It is a child of what? Child of asset. Okay. So in this hierarchy, second hierarchy, sorted set. Sorted set is a sorted set is an interface. Then interface extended from where now? Set. Navigable set extended from sorted set. Tree set is a class implementing what now? Navigable. See, whenever a class is implementing navigable set, now this class has to implement all the methods of the implemented interface as well as its parent interface. It's a now this is coming from where? Sorted set. Sorted set from set from collection. It is all the methods are present inside which class now? Preset class. Yes or no? Because this is extended from this. It means all the methods of sorted set is present here now. And this is extended from this. This is also extended from this. This collection method is also available here too in the child interface. Okay, so tree set contains number of methods because navigable set method, sorted set method, then collection method is available inside the tree set. Okay, so this is one hierarchy set. Then coming to list, list is also a child interface of a collection. Array list is a class. Array list is implementing list. Linked list implementing list. Vector is implementing list interface. And from vector we have got child class as a stack. And from Q we have a DQ, okay, double-ended Q. So it is a child interface of Q. Priority Q is a class. Priority Q is a class. Okay, this is one hierarchy. Collection has got set, list, and queue. Then we have a map. To remember set, you can remember map also. Map, same like hash map, linked hash map, sorted map, navigable map, and here we have a set. Here we have a map. Apart from that, we have two more class: dictionary, AC, and abstract class. It is an abstract class, has table and properties, and these are all called containers. Whatever we discussed now, containers. They contain other objects. They contain other objects like set, list, queue, and map. They are the containers. They can carry the other object. Once the container is carrying the other object, if you want to process the object, in order to process the object, we require cursors. We require cursors by which we can process the elements. There are three cursors. One is iterator, list iterator, and enumeration. Iterator, list iterator, and enumeration. By using these three interfaces, we can process the elements of the container. What are the elements are present in the container? If you want to process them, read them, then we need to use either iterator or list iterator, or like all are not applicable for all. We will discuss like iterator applicable for whom, list iterator for which container, enumeration for which container, that we will decide. We discuss that. Okay, but just assume now these are the cursors by which we can process the elements, and two more interfaces are required for sorting purposes to sort the data, arranging the elements in a sorted order, ascending order or descending order. We require two interfaces that's called comparable and comparator. We'll talk about this also. Comparable, all these things we are going to explore. You see the hierarchy only. Comparable and comparator. Apart from these two utility classes, one is collections and arrays. Collection is an interface, but collections is a class. It contains a lot of static methods. Arrays also contains static method. These are called utility classes. Utility classes. And if you look at this entire hierarchy, some places have written 1.0, vector 1.0, stack 1.0, dictionary 1.0, hash table 1.0, properties 1.0, enumeration 1.0, which are since 1.0. 1.0 since very beginning of Java, JDK 1.0 first version. Collection came in JDK 1.2. But since JDK 1.0 beginning, some classes were there also. There was no such hierarchy. Those were individual classes. This framework was not there. But when the framework came in JDK 1.2, then they have added all the things into this framework. But initially it was not there. So these are called legacy classes and old class. Old class and interface. They might ask you, what are the legacy class and interfaces in collection framework? Legacy class and interface, old class interfaces. Then you can list out this legacy class interfaces. Those are from 1.0, like vector, stack, dictionary, hash table, properties, and these five are class, and one is your interface. One legacy interface, five legacy class. These are the legacy class interface present in the collection framework. Okay. And see here interface extends, class is extends, interface and class is implements. Okay, so this is what we'll start with. Tomorrow we'll see what is there in the collection interface, what are the methods are there in the collection interface, and how these are implemented by all the class, because the root interface, no, what is present in collection interface, that is available to all the class. But what is present in list, that is present to whom now? Only to the array list, linked list, vector, and stack, because it is not a part of set now, right? hash set, linked hash set, tree set does not contain the method of list. List specific methods are present in the array list because array list is implementing list interface. Queue related things are there in the queue related classes. But whatever in the collection that is available to set list as well as the all three interfaces has got. Just we need to explore a little. You know, a lot of methods are there. We need to know how to use creating object and calling the method from. So we'll see tomorrow.